This is my Mighty Mite Mark III sawmill, and showed it in videos that from last summer, from 2013, cutting some yellow cedar. This is a part of the pile I cut. It's kind of a jumble right now because I threw some parts off of it to get that cant out of there. This has got a 6x cant sitting on the table. I need to make some 4x6s out of it, and so I sharpened the blade up yesterday, and now I'm going to get the mill ready for the season. And I thought I'd show a little bit of what I do for the season. Now last year at the end of the season when I put it away, what I did was I washed it down real good with the pressure washer and cleaned all the sawdust and everything off of it, off all the rails and the table, and off of the mill, the power head, and the mill itself. This is the fuel tank here. It's part of the framework. Holds right around 5 gallons of gas. This is the filler for it. I filled it up completely full of gasoline with some stabilizer, fuel stabilizer in it. In fact, I think it had a little bit of 100 low lead avgas in it, but it put fuel stabilizer in it. And then I pumped the fuel stabilizer, the fuel, it was mixed real good with the fuel stabilizer. I ran it through the carburetor and ran it for a while. After washing it down, which helped dry the motor out, the engine out, and get everything warmed up and dried out, and it run stabilized fuel through the carburetor. It had a little garden tractor battery in it, which I took off and took in the shop, charged it up, stored it for the winter. But the battery wasn't much good to begin with. It was starting to fail anyway, so I dug out this battery here to hook on it for the year, or not for the season, just to get it going. I have to get a battery that'll fit it to run it for the year, but anyway, I got this new battery on it for now, which started it up, warmed it up yesterday and checked it out. I had to start it to move the tail wheel in for two reasons. One, so I could get access to these bearings in here to grease them, and two, so I could mount the freshly sharpened blade on it. So anyway, that's part of what I did for the winter. Washed it down, cleaned it up, and we've got two chains on here. We've got one chain on here that raises and lowers the carriage, and then there's a chain on here that is the drive chain, and that chain runs the full length of the table of the mill. And those were cleaned and sprayed with lubricant. See, there's the drive assembly there, and they were sprayed with lubricant for the winter. All of the bearings were greased. Was put away to get any moisture out of the bearings and make sure they had fresh grease on them, and they were rolled so the grease got fully distributed through the bearings. And we've got bearings, of course, here on the drive wheel. This is not the drive wheel, this is the idler wheel, or the tail wheel. This is the clutch. It's a 12-volt clutch. It engages with 12 volts DC. It's self-maintained, but inside here is one of the bearings. This is the head bearing on the head wheel, and you can see the grease coming out of it. That was lubed for the winter and rolled, so the grease was fully distributed around. All the moisture was pushed out of it, and on the other side, this again is the head wheel, and there's another bearing in here on this one. It's the same bearing as on the inside. It again was lubed, greased and lubed for the winter. This side over here is the tail wheel, or idler wheel. it doesn't have a grease access from this side. For the bearing on it, there's two bearings on it, and they're both from the back side. The guide rollers, I greased those. I don't know why the grease zerks are even on those. They're just to make you feel good, I guess, because there's sealed bearings in there, so greasing those does absolutely no good for anything. That one is seized up, but these are rolling okay. But all the grease does is just go in there and come out between the shaft and the bearing, which is not only pointless, it's probably counterproductive, because it allows the bearing to spin on the shaft then instead of rolling. But anyhow, and there are zerks in these rollers. These are the carriage rollers. They roll on the tracks. There's zerks in those. And they were greased up, and then lubricant was sprayed liberally everywhere. So to get it going for the season, to check the fuel, I mean, if you're really anal on it, you'd drain the fuel and put fresh fuel in it for the season, but that fuel is good. It's about 5 months old or so, but it was stored with fuel stabilizer. And I checked the oil. Now I'm going to run it a little bit and warm it up and run it this time, and then I'm going to change the oil and filter on it. To check the belts, make sure the belt tension is good and the belts are all in good shape. This is the main drive belts for the wheel. This belt runs the hydraulic pump, and so anyway, this is what we're going to do. Up there in the top is the gauge. That's the hydraulic tank up there. Again, it's part of the framework. Holds a little over 5 gallons of hydraulic fluid. The vent up there on top, I had to replace it a couple of years ago. I've got this cover over the mill itself, and I don't have a cover over the whole rig, but I've got a cover over the head rig. And that cover we built that many years ago as a cover for a chicken coop we raised some chickens out here, and that was just a temporary cover for it that I just transferred over to the mill when I got it, and it suffices until they can get a good shed built over the mill. But it got some snow on it, and it crushed the vent tube, the vent that was on there, which caused the mill to malfunction. It wouldn't work properly, so I fabricated that vent. It's just some brass pipe screwed in there, cut some notches in the pipe for air vents, and it works fine. And so anyway, I've got to pull this top off and check the oil reservoir. You can't really tell right now by looking in the reservoir whether it's full or not, because if it's over full, what it was, it wouldn't show on there, and if it's under full, it wouldn't show on there. If it was low, it wouldn't show on there. And I think it's full, but I'm gonna pull it and check anyway. So this is what I'm gonna do to get the mill ready to go for the season. I've got chain and cable lube to lube. Now this chain in here, that's for the head rig, for raising and lower the head rig for the depth of cut. It's pretty well greased up. It doesn't need much, but I'm going to spray fresh grease on it anyway. And the other chain out here that drives the carriage, it's exposed to the weather, so even though I greased it last fall, when I put it away, I'm going to grease it again, because it's, like I said, exposed to the weather. We get a lot of rain and stuff here. The fuel is good. Oil I'm going to change. Next thing to do is to pull the air filter off and clean it. And well, that just has a little wing nut up here to take off. And I'll put it down here someplace where it won't get lost. And then the cover is kind of a pain to get off. You have to pull it up and it won't come out because of the exhaust. Pull it over until you can slide it off the screw. And so that's got a little bit of sawdust in there on the intake. We'll clean that all up and clean this filter, blow this filter out, and then we'll grease up all these zerts again. Even though I just greased them last winter when I put it away, I'll put fresh grease in them. These bearings are pretty spendy. The ones in the head and these here are about $350 a piece or so. They're Browning bearings. These I forget what these are called now, but they run on a track. They're pulled back and forth with this hydraulic cylinder to adjust the blade tension, and then you adjust the tracking of the blade with these nuts here on this pillow blocker and these blocks right here that slide back and forth. So we lube these sliders a little bit with some grease or oil, and then the blocks, we lube those real good. And I like to take and lube those bearings, put grease in them until it starts coming out, and then turn the wheel, turn the shaft a little bit and put more grease in it, and do that all the way around so it gets fully greased. The manual for the Mighty Mite says to be sparing with the grease on it, but the bearing manual says to grease them up real good. Also, the bearing manuals specify to use a moly base grease, and so this is what I've been using here. It's a Phillips 66 Union 76 Conoco Megaplex XD3 grease, 3% moly, and you want to make sure and be consistent with the grease that you use. You always want to use the same grease in these bearings, because there's two different bases for the grease, and if you mix the two different bases up together in the grease, they actually have a chemical reaction together that will cause corrosion and cause your bearings to be destroyed. So you want to make sure and keep the grease that you use in all of your bearings, not just in the sawmill, but in all of your bearings. You want to make sure and keep the grease that you use in them the same, unless it's completely cleaned out, like a wheel bearing on the car. If you take them out of the car, clean them all up, wash them all out, and then you can use a different type of grease, but otherwise you want to use the same type of grease. I'm using this Lincoln electric grease gun. It's a 12-volt one. The 12-volt ones are okay for this kind of a procedure, but they don't have enough battery lifetime on them to do large equipment. The larger 14 volts and bigger ones are better for that. But it's nice to use either this or one of the ones with the little hand pump on them, squeezer pump on them on the side lever instead of the big lever, because it always takes 3 hands with the regular grease gun to do anything. You got to have one to hold the fitting on, and you have to have one to hold the pump, and when one to pump the handle. And with these, you only need 2 hands. You can hold it on your fitting with one hand and just squeeze the trigger with the other hand and squeeze the grease into it. And with the ones with the hand lever on them, those are pretty good. They work just as good, and they help build up your forearm muscles, which I understand helps lower your blood pressure. So anyway, they work pretty good too when they work. When they don't work, they're not worth a damn, but that's typical of everything. So this is what we're doing to get ready for the year. Check the fuel. I'm going to check the hydraulic fluid, grease all the bearings, grease the chains again, check the belts, tension and the condition of the belts, and check the battery, of course, put a new battery on. This is the oil reservoir for the blade lubricant. It's just a washer tank, windshield washer tank, or windshield washer pump, and there's a little button over here to push to pump, and it actually, the way it's set up, once you get it going, it'll gravity feed, and this valve turns it on and off. And then I have I have valve right here, and I just usually crack that just a little bit to get for gravity feed, so it just drips. You can see the drip coming out maybe. Just drips a little bit at a time. Top one has to be open a little bit more because it's not quite as it doesn't have quite as much pull with the gravity on it. It's almost the same height as the bottom of the tank. So so that's the startup procedure on here. We'll grease it. The air filter has been changed or cleaned and reinstalled, and all the bearings have been greased. The greasable bearings have been greased. The chains were both lubed. More of the carriage bearings down there, rollers. And this is the idler wheel bearings. They're all greased up nice, and I lubed with chain lube. I lubed this slider for those bearings. One of the things I didn't mention that you check on these is on these wheels, of course, is to spin them, make sure they spin free. But like any bearing, if it spins too free, then the bearing might be getting worn pretty bad. But I also grab these wheels by the outside edge here and rock it a little bit and see how much play there is in there. And that one is good. And the head wheel spins good. That spins real good, and it rocks, and there's no give, no movement in it. So now the reason you want to check for that is to make sure the axial loads on the bearings or is not causing it to wear out. If you get any kind of movement in this at all, that's a good sign that that bearing is going. And like I said, the bearings are expensive. They're about $300-400 a piece. But this shaft in here is also proprietary item. I suppose you could have one built at a machine shop, but that's pretty expensive too. That this wheel runs on. This shaft extends out through here, has this hub on here for tightening it up. For this is basically just a shiv with a rubber tire put in it. But when that bearing goes out, and if you run them very long with the bearing out, then this shaft will get ate up, and you have to replace it too. I had to replace the bearing and the shaft and the wheel on this when I got it, and I replaced it with a wheel so I could run smaller bands. It was set up originally to run 1/2 inch or 2-inch bandsaw blades, and I set it up now to run 1 1/4 or thereabouts on it. But I had to replace both bearings in the shaft, and then this bearing, the started cutting off again here a couple years ago, and I kept investigating, and these bearings went bad. And when I took those bearings out and replaced them, then this shaft had been run previously on bad bearings, and it was pretty badly ate up, and I had to replace that shaft too. So those are not fun to do. So anyway, that's the maintenance. Now the next thing for me to do is to take the top off of the head rig there, the whole thing. I'm going to take the top off and check the hydraulic fluid, and to do that I'll go get the Bobcat, put the forks on it, and so I can take it off of there. Now, I mentioned I filled up the gas tank with fuel last fall when I put the thing away for the winter, and it's a good idea to fill up fuel tanks in anything when it's going to be stored for any length of time. If it's partially filled, then as the air temperature goes up and down, cold air is denser than warm air, so if it warms up in the daytime like now with the sunshine, it'll heat up the air in there, which will vent out of the tank, and then as it cools off at night, it'll draw in air, and then the air that's in there the moisture will condense out of it, and you'll get water in your tank. And that's one of the sources of water in fuel tanks. So if you're going to store it for any length of time, it's a good idea to to have your tank filled before you store it. So, I've got the cover back on over the carriage or the head rig, and everything's all greased, lubed, cleaned up, and checked. Everything's good. So the next step is to put the blade on. I use the hydraulic cylinder to pull this idler wheel all the way in so we can get the blade on. So I'll just slide the blade in. Around that drive pulley and then through this slot on the top and feed it in through the guide rails, the guide rollers I should say, and make sure that it's on these pulleys. Look at everything and make sure it's all clear. Now the next thing, okay, this oiler or the blade lube tube was down in the way. So now what I have to do is start the mill up and tension the blade. And then once you tension it, then we'll check the tracking on the blade. Kick it into gear, let it turn over, and then shut it off and come back and check it again. Okay, I put it in gear. Run it, everything is still good on it, so I'll close it up and it's ready to go. You can see we've got the big timber on there, so I've got my clamps up here, and this one is good down to 12 inches. When you get down to, it'll clear 12 inches, but it won't clear anymore. These will, down here, will clear 1 inch. We've got this one back here set. The log, the cant is not square on the table, so I'm going to get the pinch bar and square it up. Now you want to look real close at this and make sure that there's nothing up within the path of the mill or the blade that's going to interfere with it. This side is nice and clear. Now this side, I've got to, everything's all clear except for down here on this end, this clamp, the bar is sticking up in the air. So I put it sideways like that so it makes sure it clears. But I've got to adjust that cant anyway. So, okay, now, since that is a tall, narrow piece of wood on there, it can be fairly unstable. So So I have it clamped in there with the dogs on the left side there, up and locked, and the clamps on the right side up and locked. And then we have these pipe clamps down here on the bottom. They would hold it when it gets down lower, or a different size of piece. They would clamp it and hold it tight. I've got those on there now. Make sure that the ears on these pipe clamps are parallel with the direction of the cut of the mill, so that the blade doesn't cut it. Now the blade will cut down to 1 inch, and that'll clear these clamps right here. But if this ear was turned up, then the blade would contact it and cause kind of a mess. This one I'll leave it up and clamped in there until I get it cut down. I got 12 inches of clearance, and this one's actually tipped a little bit over, so I got a little bit more clearance than that. But anyway, I can take 1 or 2 cuts off of there, 1 cut off of there anyway, before I get down. Then we have another pipe clamp here. Again, that ear is down parallel with the table, and this one is parallel with the table, so we don't have anything sticking up in the path of the cut. There's my control. I can lower it down and eyeball where I want my cut to be. And down below the wane. And if I look, it gives me 18.5 inches. It gives me a little bit of wane on that. So I can go down to 18 inches. Now there's 2 lines on this plastic guide to allow for parallax. So I get my eyeball on that plastic line, and then I like to go down and then come up into it so that it take any of the cushion out of it, any of the backlash out of it. So now that cut is ready to go. Everything's clear down the saw. I'll reach in here and turn on my blade lube valves. I'll turn this valve on and get lube flowing through the lines. So we have a little bit of lube flowing through the lines there. And that drip is just about right. Okay. Plugs in, and now I like to throttle this down before I engage the blade. It takes a lot of the stress out of starting up the blade. So then we'll engage it. Once it's engaged, then I'll bring the throttle up to full throttle. This little valve right here adjusts the speed of the carriage travel. So I adjust it down to stop to start with, and then after I engage the carriage travel, I'll just slowly bring that up and keep it going real slow until the cut enters the wood. initial cut was 18, so if I want 4x6s, then the next cut will be 14. The next one will be 10. So at 10 inches, those dogs on this side will interfere with the cut. So I'm going to have to change those, drop those down. And the other end of those dogs is a smaller one, which will go down to 6 inches. So I'll just flop those 180 degrees, go down to 6 inches. But because I'm going to work in front of this blade, I take the blade, I'll take it out so it will stop moving. I'll raise the carriage back up to clear the offcuts and bring it down to this end and slow it down while I work. Setting those down and then putting them at an angle, that drops them down even a little bit lower. Now I have to change the clamps on this side. My last cut was 14, so now I'll bring it down to 10. Will be 6, and I should have plenty of clearance on those clamps for 6 inch, but it also is small enough now it should be stable for just the pipe clamps underneath. So I'm going to bring it back this time and take it out and disengage the clutch so that the blade stops, and bring it back, slow it down, and I'll just take those clamps off of it now, the dogs off of it, and it'll just be held on with the pipe clamps now. Now, every time I do this, I want to make doubly damn sure that there's nothing protruding above the path of that blade. And right now, I'm good to go all the way down to 1 inch. Everything is clear. There's no ears sticking up. There's no chunks of wood or metal or anything sticking up above that path of that blade. So I'm good to go. So now the next cut will be 6 inches. And then the following one will be 2 inches, so that'll give me 4 4x6s and 1 2x6. One of those 4x6s is going to be 4 inches minus the curve of the blade, which is approximately 1/8 of an inch. So they're going to be 3 7/8. That last board is set on 2 inches. That's a full 2 inches because that's measured up from the bottom. That doesn't have any curve on it. That's the last cut, so I'm going to raise this carriage up underneath well underneath the roof, and disengage the blade and put it away. Now we have 4 4x6s to use to build my porch. Back here, we'll reduce the RPM of the engine, going down to a little more than an idle, and let it cool off for a while. I'll release the pressure on the band blade, and then after it cools off for a few minutes, I'll shut it down and I'll take the band off and shut it down.
sharpen it?
No, I'm all done.
Oh, you're all done?
That's all I need to cut. So, no, it's plenty sharp. Just take it off. Yeah, just leaving it out here in the rain. That's all ready to go. Ready to go. I'll have to sharpen up some more blades to do anything with. I just got this one sharp, but all the rest of them I need to fix the back of them and set the teeth and stuff like that. I've never used that tooth setter.
Tooth setter all going.
I have to learn how to use it. What are you doing, Stinky? What are you doing, Stinky?
Yeah, she chased chickens.